So I want to talk to you about this homework problem because I think it's a little bit tricky. Okay, so the idea here is that we want to find the delta so that if x is within delta of 0.8, then when we plug it into this function 1 over x squared, that result will be within 1.9 of the actual limit itself. Okay, so let me draw you a picture. So if our function here is 1 over x squared, that kind of looks like this. Right, so it kind of looks like 1 over x. On the left side, it will look like that, but we're mostly concerned with what's happening at 0.8. Okay. So let's say it falls about there on the curve. The idea is that when we plug this in, we get 1 over 0.8 squared. And I'm going to go ahead and type that into my calculator. I encourage you to do the same, just to make sure that you're doing everything right on your calculator. I get 1.5625. And so that's this value over here. That's the actual limit. 5625. What we're interested in is we're trying to keep the values we're plugging in. We're trying to keep their outputs within epsilon of that. So in this case, epsilon is this 1.9. So think about taking this number here and adding 1.9 to that and subtracting 1.9 from that. So L plus epsilon will be 1.5625, our actual limit, plus this value. So that will be 3.4625. I can do that one in my head because it's like adding 2 and then subtracting a tenth. And then if I subtract it, L minus epsilon, well, that one's a little bit trickier. That's going to end up going negative, right? So we get 1.5625 and we're subtracting 1.9 and we wind up with negative 0.3375. Okay, so if I draw these values on my picture over here, I have this is not to scale. I'm just going to put 3.4 and negative 0.3 down here. Now, one thing that makes this tricky is because that value is negative. So on this right side of 0.8, kind of no matter how far out you go, let's say you got to here, your value is never going to be negative, right? It's always staying at least 0. So you don't actually have any concerns on that right side. No matter what you plug in, it will be within that bound. What's happening is on the left-hand side. That's really where we need to be concerned. We need to be thinking about, what values can I plug in to make sure that I'm not going outside of this range. Sort of what is that value? Okay, so to solve that problem, we can think about what happens when I take 3.4625 and I set it equal to this 1 over x squared. Sort of what value do I get for x? So what I'll do is I will sort of invert both sides, right? Think about taking 1 over both sides and then taking the square root of both sides. So let me type this into my calculator. Again, I encourage you to try this at home just to make sure there's no calculator issues. So I do 1 over this, and then I do the square root. And I get 0.53741. We'll call it there. Okay. So this is about 0.53. But delta is going to be the difference between those two numbers. So I need to take 0.8 minus 0.57341. And again, what I'll do is I will use my calculator. and I get 0.26259. Okay. So on the left-hand side, that distance will guarantee that my y value is within the right range, right? That I'm not leaving this part here. And so that's on the left side. On the right side, if I go out that distance, of course I'm fine. I'm still fine because I can never go negative, okay? So that's going to be the largest value of delta. Now, the one thing I want to show you is a different way of looking at this. So I've seen a lot of students sort of try to solve this for x, and that is a good method in these cases, to think about, oh, I want this value to be between negative 1.9 and 1.9. Why? Well, because it's the absolute value. And then sort of pull this stuff around. I mean, what I'm doing when I add 1 over 0.8 squared to both sides is I'm computing the numbers that I found here, right? That I did right away. This number 3.4 and negative 0.3. And so what happens here, I get negative about 0.34. And I get positive about 3.4, not exactly, but about 3.5, I guess, 3.5. And then I can try to flip it and solve, but the problem is I'm going to be taking a square root of a negative number. And that's bad. That will not work. That won't do it all. And so if you can use that method of directly solving for it, that's great. Go ahead and do that. But if you run into issues, try to draw the picture. The picture is what will really help. And that's what helped us figure out that, because this is negative, we don't really have to worry about this right side at all. No matter how far out I go, I'll be within the right bound.